Hello everyone. The main purpose of this video is to help the second PU students who are about to write their final exam in the month of April 2022. Here in this video, I'll be dealing with the 1-mark questions. This time there will be 15 questions, out of which the students will have to attempt 10 questions. The first 2 questions will be from relations and functions, next 2 questions from inverse trigonometry, 1 from matrices, 1 from determinants, 2 from differentiation, 2 from integration, 2 from vectors, 1 from 3D, 1 from LP, and 1 from probability. Let's now go through each one of these questions one by one. The first question from relations. So to answer these questions, one needs to know what is the reflexive relation, what is a symmetric relation, and what is a transitive relation. The definition of these relations are given here. That is, a relation R is said to be a reflexive relation if for all A belonging to A, the ordered pairs of the type A, A must belong to R. Symmetric relation is if A, B belongs to the relation R, then B, A must belong. So when do I say a relation is not symmetric? The only case when the relation is not symmetric is A, B belongs to R, but B, A does not belong to R. In fact, all the other relations are symmetric itself. Coming to the transitive relation. A relation is said to be transitive if A, B belongs to R and B, C belongs to R. Then A, C should belong to R. Now, the only case where the relation cannot be transitive is that A, B belongs to R and B, C also belongs to R, but A, C does not belong to R. Rest all the relations can be taken as transitive relations. Let me try one question here, students. The first one. Give an example for a relation which is symmetric and transitive but not reflexive. So whenever we give an example, we need to define the relation on the set. Let me take the set as A equal to 1, 2, 3, and the relation, let me define it as 1, 2. To make it symmetric, I will have to write 2, 1. And to make it transitive, I will have to have 1, 1, also 2, 2. Yes, that's it. Now, this relation is symmetric as well as transitive, but not reflexive because 3, 3 is missing here. Though 3 is an element of A, but in the relation 3, 3 is missing. Therefore, it cannot be reflexive. Let's move on to the next question. This question will be from binary operations. It may be a definition. Very often they have asked a question like this, or it may be a question where you will have to check whether the operation is binary operation or not. So what is a binary operation? An operation star on a set A is said to be binary operation if it satisfies these 2 conditions. What are these 2 conditions? The conditions are for any 2 elements from the set. If you apply the operation on those 2 elements, the obtained answer must be in the same set A. That's the first condition. Second condition is, whenever you apply the operation on any 2 elements of the set, the answer must be an unique. That means it must be a single value. Yes, let me try one question here. Maybe the 5th one, let me try. Let star be a binary operation on n given by A star B is equal to LCM of A, B for all A, B belonging to n. Now, I will have to find out the value of 5 star 7. So 5 star 7 is, according to the definition here, it is nothing but LCM of A, B, that is 5, 7. So that is equal to, what is the LCM of 5, 7? It is nothing but 35. So that's it. Let's move on to the next question. In fact, this is the continuation of the second itself. The second question also can be based on the properties of binary operations: commutative property, associative property, identity property. So let me try one of this. That is the fourth question I want to try here. That is to find the identity element for the given binary operation defined as A star B is equal to AB by 4. Very often they have asked this question. In fact, the other questions are also important here. So how do I do this? Let E be the identity. So what is an identity basically? The definition says here, an element E is called as an identity if for any element A star E or E star A, both must be equal to A. In that case, we call that E as an identity element. So according to this definition, if E is an identity element, we have A star E is equal to A. Now by the question here, we have A star B is equal to AB by 4. That means A star E must be equal to AE by 4. That is equal to A. Now simplifying it further, A gets cancelled there. E will be equal to 4. That's the required answer. The identity is 4. Let's move on to the third question. In order to answer this question, we will have to know a few formulae here. The formulas are, when there is a negative sign in the inverse trigonometric functions like this, what should we do? So in the case of sine inverse, tan inverse, and cosec inverse, the sign can be written this way: minus of sine inverse of x, minus of tan inverse of x, minus of cosec inverse of x. But in the case of cos inverse, sec inverse, and cot inverse, if there is a minus sign, then you will have to write it as pi minus cos inverse of x, pi minus sec inverse of x, pi minus cot inverse of x. So using this formula, let me try one question here. Maybe I would like to do the first question. So cos inverse of minus 1 by 2. I'm going to use this formula here, that is cos inverse of minus x is equal to pi minus cos inverse of x. So accordingly, I get here pi minus cos inverse of 1 by 2. This is equal to pi minus cos inverse of 1 by 2 is nothing but pi by 3. On simplifying this, I get 2 pi by 3. That's the required answer. Let me move on to the next question. The fourth question is again from inverse trigonometry. Here, for these first three questions, we may have to use the formula like sine inverse x plus cos inverse of x is equal to pi by 2. In fact, sec inverse of x plus cosec inverse of x is also equal to pi by 2. Tan inverse of x plus cot inverse of x is also equal to pi by 2. So if you know those formulae, easy formulae, you will be able to answer these questions easily. Okay, in fact, for the next three questions, you will have to check your textbooks where they have given what are the possible values of x for which these properties hold. So you'll have to learn them by heart, and then you'll have to write it in the exam. But let me try one question here. That is the first question itself. Let me try. So what is given here? The first question is sine inverse of 1 by 5 plus cos inverse of x is equal to, I'm going to shift this sign to the other side. It becomes sine inverse of 1. This becomes sine inverse of 1 by 5 is equal to, sine inverse of 1 is actually equal to pi by 2, and cos inverse, I'm shifting it to the other side. It becomes minus cos inverse of x. This implies sine inverse of 1 by 5 is equal to, what is this value? This is nothing but, using this property, it can be written as pi minus cos inverse of x is equal to sine inverse of x. So I'm going to replace this by sine inverse of x. So from this, it is very clear that x must be equal to 1 by 5. In the same way, the other questions also you could try, students. Let's move on to the fifth question. The fifth question will be from matrices. It could be a question based on the definition. Even the fourth question is also based on the definition itself, that is a scalar matrix. The fifth, the sixth, and the seventh question, as you see here, it is to construct the matrix. Often they used to ask this kind of questions earlier. And there's also one more possibility where they could ask you to find the possible orders of the matrix for a given number of elements. So let me try one question here. That is the fourth question I want to try. The fourth question is, it is given that the matrix is a scalar matrix. What is a scalar matrix? It is a rectangle. A scalar matrix is a square matrix in which the diagonal elements are all equal. So that means the all diagonal elements here must be 4. That means x plus 2 must be equal to 4. That implies x must be equal to 4 minus 2, that is equal to 2. We got the value of x, that's done. Next, I need to find out the value of y, for which in a scalar matrix, the non-diagonal elements must all be 0. So that means y minus 3 must be equal to 0. That means y must be equal to 3. So we got the answer. Values of both x and y. Let's move to the next question. The sixth question is from determinants. Here we have actually 3 types of questions. So the first 3 questions, as you see here, they have given us 2 determinants which are equal to each other, and we will have to find out the values of x. And the next 2 questions, where a matrix is given to us A, we will have to find out determinant of 2A or determinant of 3A. And the last question here, sixth one, is where the given matrix is a singular matrix. That means the determinant equal to 0. We will have to find out the value of x. So it is a very simple question. You equate the determinant to 0 and then expand it along whichever the row or the column you want, and you will get the value of x. Here, let me try the third question. So usually students sometimes make mistakes. The common mistake here people do is they will simply equate x equal to 6, they will say. In this problem, in the first question, it will be definitely correct. In fact, if you check the second question also, if you say x equal to 2, the corresponding elements, if you equate, you will get the right answer, 2 itself. It is right, you will get. But in general, it cannot be done that way. Let me see the third question here. If you simply equate x equal to 2, you will go wrong. Or if you say x equal to 4, the corresponding element, if you equate it, you will go wrong. So let me try the third question. So the determinant of the first matrix is 3 minus x square is equal to, the determinant of the second one is 3 minus 8. 3 gets cancelled. This implies x square is equal to 8. And this implies x is equal to plus or minus root 8. That could be written as plus or minus 2 root 2. So this must be the right answer. Let's move on to the next one. The seventh question. This time we'll have 2 questions from differentiation. Most probably both questions may be using chain rule itself. Let me try the first question here. The given function y is equal to e to the power cos x, and the derivative y dash is given by e power cos x into the derivative of cos x is minus sin x. This is how you can solve these questions. Let me try one more question. The second one is y is equal to e to the power x cube. Now y dash will be equal to, the derivative of e would be e power x cube here, into, next I'm going to differentiate x cube using the chain rule. I get the derivative as 3x square. So this would be the right answer. Let's move on to the next question, 8th question. Again, this is from differentiation itself. Let me try one question here. The first question. The given function y is equal to sine of x square plus 5. So y dash will be equal to, the derivative of sine is cos of x square plus 5 into, next we will have to differentiate this function, that is 2x plus 0. So this would be the final answer. Let's move on to the ninth question. The ninth question will be from integration. Often it will be a simple problem, so any students could attempt this question. Let me try the first question here. The integral of 2x minus 3 cos x plus e power x with respect to x. So usually what we do is, if a constant is there along with the function, that constant is written as it is, then the integral of x here is x square by 2 minus 3 will be written as it is since it is a constant, and the integral of cos x is sin x plus integral of e power x is e power x itself plus c. Don't forget to write plus c, students. You might lose a mark. Here 2 can be cancelled. So this is the final answer. So all these questions are very simple questions. If you want, let me try one more question here, the fourth one. Fourth question, the integral of sine of 2 plus 5x with respect to x. So the integral of sine is minus cos of 2 plus 5x. But in the place of x, if we have any other linear expression, then we will have to divide the integral by the derivative of that expression. That is, the derivative of this expression is 0 plus 5 plus c. Don't forget to write c here. Yes, that's the final answer. There's one more question from integration. So here, the only difference maybe we have the limit here. So let me try the first question, the integral of 1 by x from 2 to 3. The integral of 1 by x is log of mod x from 2 to 3. That is equal to, first we are going to apply the upper limit minus log of the lower limit is 2. Using log property, we have log 3 divided by 2, which is the final answer. Let's move on to the 11th question. This question is from vectors. The two possibilities here, the question could be based on unit vector, where the unit vector is given by the formula a cap, that's how we denote the unit vector, is equal to the vector divided by its magnitude. Or you can have one more possibility, that is the direction cosines could be asked. So whenever a vector is given like this, the direction cosines are actually cos alpha, cos beta, cos gamma, where alpha, beta, and gamma are the angles made by the vector with a positive x, y, and z axis respectively. So the formula for cos alpha is x by magnitude of vector A, cos beta is y by magnitude of vector A, cos gamma is z by magnitude of vector A. The formula seems to be very easy here. So let me try one question, how to find out the unit vector in the direction of the given vector. So the first question here, the given vector is A. So let me write A cap is equal to vector A divided by the magnitude of vector A. So this will be equal to 2i cap plus 3j cap plus k cap whole divided by the magnitude. How do you find out the magnitude? It is the root of the squares of all the scalar components here. That is 2 square, that will be 4. Next 3 square, that is 9, plus 1 square is 1, which is equal to 2i cap plus 3j cap plus k cap whole divided by root 14. This is how we could answer these questions. Let me move on to the 12th question. Again, this question is from vectors where it may be a definition. What is a unit vector? What is the negative of a vector? What are collinear vectors? Or give example for two vectors which have the same magnitude but different vectors. So let me try this first question. Let me give one example. Vector A is equal to 2i cap plus 3j cap plus k cap. Now the other vector would be, it has to be a different vector but magnitude should be same. So what you do is you just rearrange the scalar components here and write the same vector. That is, let me start with 3i cap, okay, then 2j cap plus k cap. So the scalar components have just rearranged them and I get a totally a different vector, but the magnitude of these two vectors will be same. The fifth question is where you will have to check whether the given two vectors are collinear or not. What do you mean by collinear vectors? Collinear vectors are those vectors which can be written in this way. A and B are said to be collinear if vector A is equal to some scalar times vector B. Let me check it here. The fifth question, the fifth one. The vector B is equal to minus 4i cap plus 6j cap minus 8k cap. Let me take out minus 2 common here. Let's see what I get. I get 2i cap minus 3j cap plus 4k cap. That is equal to minus 2 times. So what is this vector? Isn't it nothing but the vector A itself? Yes, it is the vector A. So I was able to express the vector B is equal to some scalar times the vector B. Therefore, A and B must be collinear. Okay. Yes. The 13th question. This question is from 3D, where you will have to find out the direction cosine of the vector, most probably, I guess. So if it is the direction cosine, the direction cosines are cos alpha, cos beta, cos gamma. And how do we evaluate them? If x, y, and z are the direction ratios of the given line, then the direction cosines are given by the formula shown here. Also, you must remember cos square alpha plus cos square beta plus cos square gamma is always equal to 1. So let me try one question here. See the second question, actually very simple question where the angles are given to us, that is alpha, beta, gamma. So you can directly evaluate what is cos alpha, cos beta, cos gamma. So that can be done easily. Here in the third question, they have given you the direction ratios. Whenever the direction ratios are given x, y, and z, x, y, and z, the formulas are these. Okay, you could use this formula. Let me try the fifth question. The fourth question. Find the direction cosines of a line which makes equal angles with the positive coordinate axis. It is making equal angles means alpha is equal to beta is equal to gamma. This implies cos alpha is equal to cos beta is equal to cos gamma. So if I find cos alpha is enough, I would get to all the three values, isn't it? Since all three are equal. So since they have said all the three angles are equal, using this formula, the second formula, I'm going to write cos square alpha plus cos square, instead of beta, I'm writing alpha itself since they are equal, plus cos square gamma, but instead of gamma, I'll write alpha itself, which is equal to 1. This implies 3 times cos square alpha is equal to 1. That implies cos square alpha is equal to 1 by 3. That implies cos alpha is equal to plus or minus 1 by root 3. Therefore, cos alpha is equal to cos beta is equal to cos gamma. All three are is equal to plus or minus 1 by root 3. Let's move on to the next question. This question is from LPP, and from so many years we have been seeing these are the three questions they have been repeating, and if you learn these 3 questions, I'm sure you will be uh, definitely getting 1 mark. So what is the first definition here? Define a feasible region. Simple definition. If you have understood the LPP problems, you don't have to learn these definitions by heart. You can just, from your understanding, you can say a feasible region is a region bounded by the constraints, or you can say it is the region determined by the constraints of an LPP problem. Or the second definition is objective function. What is an objective function? It is a linear function which needs to be either maximized or minimized depending on the problem. So you can write it as it is a linear function which needs to be either maximized or minimized subject to the constraints. And the last definition is what is the optimal solution? The optimal solution is it is a point in the feasible region which gives the optimal value for the objective function. So please go through this definition, students, and this question has been coming over and again. So let's move to the last question. Here, this question will be from probability. Very often, it is the conditional probability itself. Once in a way, it may be a problem based on the independent event, but mostly from conditional probability, for which you will have to remember one simple formula. That is the probability of A given B is probability of A intersection B divided by probability of B. So let me try the first question here. I need to find out the probability of A given B. Probability of A given B is equal to probability of A intersection B divided by probability of B. All the required data they have given us here, that is 0.32 divided by 0.5, which will be equal to 0.64. So easily you could try these problems. So that's it, student. Let's meet in the next video that is about the 2-mark questions. Thank you. Take care.